The Q and What Show with Levi K. Zwana.
My name is Levi Kamara Zwana, and I'm a software engineer. I like to think about it like system design and kind of stuff. So today I am going to be answering some questions, and yeah, this is the Q&A show, and I'm hoping I'm going to answer. Now this is according to me, not some generalized perspective. So don't expect too much of blurred lines. I don't like too much blurred lines. This is not about figuring out which one of the genders you are. Those ones, there are a lot of blurred lines over there, especially with this kind of era. So I'm going to give you straight answers. If there is no straight answer to give, I will most likely just tell you that there is no straight answer. But if I have my own straight answer, trust me, I'm going to give it to you. All right? So, the first question here is, what are the levels of engineers? How do you know which level you are? All right. Now, I've seen interviews or job openings that say level 1 engineer needed, level 2 engineer, level 3, and all of that. And sometimes I used to wonder what differentiates these two people. So, well, the first one, level 1 is more of, it's a junior or entry position. Oh, by the way, I'm a Liberian, so if you are able to get my accent, well and good. Fine. So for level 1 engineers, you give them the problem, like you specify what the problem is, and you also tell them what the solution is and how to implement the solution. That's one way you can know, what is who is a junior engineer or something like that. For level 2, now level 2 is more of mid-level kind of thing. At this point, people are thinking for themselves, So you say what the problem is. Now, you have to be clear with the problems most of the time. And then they will propose the solution and implement that solution. All right? So they propose the solution, implement the solution. Now, for level 3 engineers, this time around, you give them a business area. You see, they do not need a very clear description of the problem. So consider all these engineers to be problem solvers. Now, what makes them to leap from one level to the other is how human they are, okay? So for the level 1 engineer, you see, he's more of a straight algorithm. Give him the problem, give him the solution, he implements. Level 2, you gave him the problem, he kind of tries to figure out the solution. Level 3, now this one is coming to more humanity. Most of the time, people don't know the problems they want to solve. I can tell you, we've worked with projects, and you spend 2-3 weeks just helping the owner of the system define what the problem is, So being more human, actually identifying with human more, because most times people know what they don't want, but they do not know what they actually want, okay? So level 3 engineers, they are able to define the problem. So you give them the business area, you tell them the circumstances, and they are able to extract the problem, define a solution, and implement that solution. Okay. Now, level 4 engineers, these ones, they predict the problem and prevent it. So you can go up to level 5, all of that, but I'm going to stop here. So level 4 engineers, this could be a problem, or he's understanding the business from a holistic perspective. So it's like, I'm not just sitting behind the PC. I'm looking at how users are using the system. I'm getting customers' feedback. I know the product we are offering. I know what differentiates us, and I know exactly how it was implemented. So then I can be able to predict what could be a future problem and build the system right now to prevent that problem. So as a level 4 engineer, sometimes you realize that the problem you say will occur, but most time you are at the top making decisions anyway. But just in case there is someone above you and you are telling them, okay, we need to prevent this problem, because you actually prevented that problem, they never really experienced the problem. So they're like, what did you solve? He said, no problem. I just died on the cross so that you can be healed and saved. I was your savior. All right. So that's basically what I would say. That's how you know which level of engineer you are. Okay. I hope that gives you a little bit of clarification. Then, all right. So how do you then think as a level 3, level 4 engineer? How do you think as a senior engineer? So let's say coming from mid level. Now I will put this in my shoe. From mid level, I think I was more focused on data structures and algorithms. You know, at this point, I wasn't just trying to implement a solution. I was trying to get the optimal solution. So it was like being clever and stuff like that. Those times we used to name variables like nums or k is equal to something. But in the end, the focus was more on the solution I gave needs to be efficient. So doing complexity analysis, I'm even struggling. Yeah, and you know, trying to foresee where there could be a bottleneck. But I think I did that more in level 3, because level 3 now I started thinking in terms of the environment in which my system is running. It's no longer just about the system itself being, you know, like the solution. It was about this particular software is going to run on a server, and this server has a fixed RAM, it has a fixed CPU, threads. So as opposed to just, okay, this is the solution, can this solution execute in parallel on 1000 threads? Okay, I mean, for concurrency's sake, we know that these things don't really execute in parallel, except you have multi-core and they are running parallelly on those cores. But if 1000 users hit this particular part of the application, can this algorithm work well in the environment? All right. So as I was thinking along those lines when I was level 2, level 3 engineer. Yeah, I think level 3, really I focus more on efficiency a lot. And now not just efficiency in terms of time complexity, but efficiency in terms of the resources. What do I have at my disposal? This is a single server and all of that. So when you get to the level of level 3, level 4, when you are writing code, this time around you are not just thinking, because you have the solution, man. You've come from level 2, except you jumped that stage. But I don't think it's possible to jump level 2, because if you see a level 2 engineer who says he's a senior engineer, you will just see his code and you'll be able to tell, or the way he talks about the problem, or the way he prioritizes his solutions. You will be able to tell whether this guy is actually a senior engineer or not. So for level 3 and level 4, you look at maintainability. Okay, like when I'm writing code these days, I'm like, okay, how can I build this stuff such that the next person after me, in case they need to make a change, will make minimal changes to these various part of the application. Because in as much as we are looking at maintainability, you don't want the application to break every single time someone change something or something needs to be added. One of my core, again, is extensibility. I usually say I do not want the code to be the blocking requirement between a market problem and the solution. It's like, how fast can the system adapt to the market? You get what I'm saying? So when I'm writing code, let's say for example I'm trying to build like a payment system. I mean, definitely what happens if there's a new payment method? What happens if we enter a new country? How much work do we have to do before we go live? And I, as a someone who like to look at extensibility, I try to engineer at that point such that when it's time to add a new payment method, it's a matter of creating a new class that implements an interface. You literally just defined the various things to how do I say, to satisfy that interface before. And right after that, we should have that payment method. That payment method should be live. You should not go, to touching the clients of the payment method. Now, the client of the payment method is more of what are the components that are using the payment method. Maybe order is using payments. Payouts is also using payments. So you don't want to go modifying those other things just because you want to add a new payment method. So that's another way. So the first one, you are thinking in terms of maintainability, is no longer just writing X is equal to 1. You are prioritizing, clarity over cleverness as a senior engineer. You want the next person that will maintain this thing to take very little time. The errors should be easily, deductible, I would say. They should be able to find the errors as fast as possible. And then being able to maintain, extensibility. Design patterns, you get to realize when you come from level 3, you will actually solve some problems, mainly when you are thinking in terms of resources and you start thinking in terms of maintainability, extensibility, and the scope of the problem you are solving as a business. You see, here you are not just on the computer, you are part of the top level, runner of this organization. So you know the market, you know where the problems could be. And so in that stage, when you start considering extensibility, maintainability, preventing problems, you will solve certain problems in a way, and then when you go and realize it, oh, this is actually the factory pattern, or this is the visitor pattern, or this is the builder pattern, and then you get to appreciate design patterns more. You see, design patterns tend to be very, very used by senior engineers. However, it's also important for you to actually make mistakes, because so many engineers take these things as rituals, like a Bible. As an engineer, you should use design patterns, but they have really never gotten to experience why design patterns are necessary. But if you make an error, you build something that when you try to build again, oh Lord, now you will realize why design patterns are important. So it no longer become a part of a Bible, like an engineer Bible, or you should follow this pattern. No, it become more of this is necessary. It's necessary for extensibility. I remember in university at the time, we had some students, and our teachers would say, use GitHub. For us it was more of ritual. Okay, for me at that time it was not ritualistic, because I had already started working on my startup after first year, and I literally built a web application procedural in a procedural programming paradigm. And then I realized why OOP was important. So for me, everything I was being taught, because I was running a startup, it was becoming real to me. And that's why by the time I was graduating, I wasn't a junior engineer. Okay. So some people, the laptops we had, they were not very good. They had worked on their projects all year. And then maybe they had this misbehave. And all of that just go into smoke. People cry. People are hurt. Thank God for the school. They were understanding. So they definitely gave some people time to redo. But after those times, those people, GitHub became part of their life. Their lives, Git and GitHub became part of their lives. So it was no longer just a developer Bible kind of religious practice of putting your code on Git, and GitHub and stuff. So yeah, that's how it should be for you as an engineer. You work on some problems. Immediately when you are close to the ground, like some startup, you get to see the errors you made, and that really it makes you to move fast, and you get to think in terms of first principles. You live from just religiously living as a software engineer to experientially living, the methodologies or the doctrines that you believe. Yeah, I could become a pastor. All right. Yeah, so I've just told you how to identify the levels and how to think. One way to get there really fast is whenever you are writing code, think about, if an intern comes today, if a junior engineer comes today, and I want him to change something and I want him to add a new feature, how much damage will he cause? How much does he have to learn? Because you see, The 80-20 principle says if you're a manager and you always have to tell your subordinates what to do, that's a very inefficient use of your time, because you are spending more than you are being rewarded, right? So can you just give him pointers, or can you look at some part of the code and literally add a new feature? Like the concept of the payment methods, or I remember, there was this time I had to convince my boss why we needed to change the whole how do we call it, the architecture, because we were serving multiple businesses and each business had its own requirements. So instead of modifying the code for every business, I had to literally throw away the whole code, start again, and made the architecture to be modular. So for every merchant, you can develop like a module, and then it's like a plugin kind of system, so that different merchants have different. So the whole system had to be behavior based, and that's the behavioral design pattern. So instead of coming from where we are modifying the code, we build the core architecture to be behavioral based, where things can hook into various events. Things are built based on the modules that are active, that are active for the current business that is using the app. So things like that, right? When I'm sitting over there, I'm like, if someone comes after me, if I have a junior engineer right now and I want him to develop a module, how much work does he have to do? How much changes does he have to make? Because then at that time, your brain now gets into thinking. You see, when you care about something a lot, your subconscious goes into action. So you sleep and you wake up and you have a better way of doing it, right? So caring for the person that is coming after you, and how much work you have to do when it comes to teaching them, and how much work do they have to do to learn, because that's a cost. If onboarding is very expensive, that means you will get developers and it will take them like 6 months before they start doing productive work. You don't want that. Someone come in 1 month maximum, they should be able to produce something with minimal damage to the current, the current code, the current system. And second thing, try to prevent problems. Try to see what you are doing from a holistic perspective, from a customer level perspective, or business problem perspective. And at that area, you are not just looking at code as, a single file that has an algorithm. You are looking at a whole module, a whole component that is executing something, right? And then you are able to see, okay, as the users use this thing, you can't go. I tell my team most of the time, if something does not go your way, it's a problem you have to solve. If people do not think the way you want them to think, it's a problem you have to solve. You can't go teaching 100,000 customers that, this button here, you should click this button, don't click this one. If you want to come to this place, click this button. Or you expect them to do it, and then when they don't know it, you get angry. I mean, if they don't know it, that's a problem you have to fix. How can you make them know it? You understand what I'm saying? So looking at it from a holistic perspective, trying to prevent problems. It's very important to prevent problems. If you want to go on vacation, you need to write code that will solve the problem of 2 years from now before it actually shows up. Yeah, so I know I've answered, in detail, but next time I'll be talking about design patterns. I even made my own front-end framework called OpenScript.js, and it was about, as a backend engineer coming to the front end, separating. I didn't used to like tying the logic to the component. I wanted serious separation of concern. So there's something called the mediator or component view kind of pattern, where I separated the components from the logic. Now, those are specific kind of logic, get things that update the UI and do not require any changes to the server. Those ones you can keep in the component, maybe fetching some data. But things like that really affect some kind of UX, or it's making some changes, modifying data, sending it back to the server. Those kind of stuff you don't want to mess around, with the components, as we have very fat components. We don't want those kind of stuff. So OpenScript. And then I didn't used to like those angle brackets, those angle brackets that we used to like in JSX and JSX. I didn't used to like those ones. So I made there's OpenScript markup. You should check it up. I'm going to leave the link in the description below. Just check it up. I have documented it. I also use AI to help me with the documentation. But I started working on this thing in like 23. It was recently in like 2020, the end of 2025, when I started fixing some memory leaks problem. Oh my lord, it was the first time I had to deal with memory leaks. But you should check that out. I will be leaving, stuff here, and if you have not liked the video, if you have not subscribed, please do so. All right, subscribe, and you just hear me talk. And I hope you can understand what I'm saying. My name is Levi Zwana, and I'm a software engineer. I also have a startup, so I'm a CEO too. So if I'm dropping all these gems, it's not just from an engineering perspective. So you have a lovely rest of your day or rest of your night. It depends on when you are watching this video, in a way.